Hello everyone, this is Mr. Molo with the 6.2 lesson called Describing Functions. So most of this lesson should be review. They're pretty much going to ask you two questions. Is it proportional and is it linear? Both of which we talked about in the past. And they're going to have you fill out some tables here, which we've done in the past as well. So the table shows the amount of rainfall in various amounts during heavy rain. Complete the table. And then it also says right here that the U.S. Department of Agriculture defines heavy rain as rain that falls 1.5 centimeters per hour. So we can look at the table and start filling it out. So after 0 hours, well, it hasn't rained yet, so 0 inches of rain have fell. Then like it says, it's 1.5 centimeters per hour. So after 1 hour, we have 1.5 centimeters. After 2 hours, we're just going to double that. 2 times 1.5 is 3 centimeters. 3 times 1.5 is 4.5. 4 times 1.5 is 6. And 5 times 1.5 is 7.5. Then it wants to know how much rain fell in 3.5 hours. So then we're going to multiply 3.5 by 1.5. So if you have your calculators out, you can do that. And you figure out it's 5.25 centimeters. Then it wants us to plot the points. We can do that. And then what do you notice about all the points that you plotted? So if I plot my points here, so 0, 1 and 1.5. Oops, 1 and 1.5, not half an hour. 2 and 3. 3 and 4.5. 4 and 6. And then 5 and 7.5. So what do we notice about all the points we plotted? And we should notice that they are in a straight line. If Mr. Molo could draw a straight line, that's pretty good. So we know that they are all in a straight line, which means they would be linear. So when we see a graph, it's really easy to tell if something's linear. Is it a straight line? And then is the total amount of rain that falls a function of the number of hours that's been falling? So then yes, it is, because we can put in whatever number times 1.5 and we could figure out how much rain has fallen. Okay, we'll move on to some other examples here. So if I look at example 1, the temperature was down 8 degrees and then steadily increased 2 degrees every hour. The equation 2x plus 8 gives the temperature after x hours. State whether the relationship with the temperature is proportional or non-proportional. So remember, the difference between proportional and non-proportional is, does it start at 0? So remember, things like Netflix are proportional. So you pay $9.95 a month no matter what. There's nothing else there. So 9.95x. So we don't have to worry about anything there. It's proportional because of that 0. You can watch 1 hour of Netflix and you still get charged $9.95. You can watch 100 hours of Netflix and you still get charged $9.95. So that doesn't matter. But something like this, where we're knowing that it starts at 8 degrees and then goes up every 2 degrees an hour, we can kind of figure out then, well, it's not proportional. The other example we usually give in class is about pizza. Let's say a cheese pizza costs $8. And then it's $2 per every topping after that. Well, if you want a pepperoni pizza, you're going to put in a 1 there. So 2 times 1 is 2 plus 8 is 10. Well, now you have a $10 pizza. So the base price, the lowest it'll go, is $8 for that plain cheese pizza. And then every topping you add after that. So this is not proportional because it's going to start at 8, not start at 0. And then it's kind of the same thing here. So then if you wait 2 hours, it's going to be 12 degrees. You wait 4 hours, it's going to be 16 degrees. You wait 6 hours, it's going to be 20 degrees. And they go ahead and did the graph for us there. So we could see it's a straight line. So it is linear, but it didn't ask if it was linear. It asked if it was proportional. And since it does not start at 0 right there, we're going to say no, it is not proportional. Number 2, state whether the relationship between x and y is proportional or non-proportional, then graph it. Again, I don't see a plus a number there, so I know this is going to start at 0, 0. So then I know it is proportional. Just going to write pro there. And then our slope is 1/2. So that means I'm going to go up 1 over 2. And so that would be my graph then. Let's look at some other examples. Here, a square tile has a side length of x inches. Graph the equation y equals x squared. Given the area of the square tiles, determine the relationship is between x and y is linear. If so, is it proportional? So this is going to be the new part. So linear, we're going to be looking at the equation. And it's kind of backwards. There's some ways to tell if it's nonlinear. So I'm just going to tell you how it's nonlinear. And if it doesn't break one of these rules, then it's going to be linear. The first rule we're going to talk about is it's nonlinear if it has an x squared, which this one does. So I just gave you the answer for this one. This one's not going to be linear. Another thing it can't have to be linear is a square root of x. It can't have an absolute value of x. It can't have an x times a y in there. And it can't have an x divided by a y. So if you see any equations that have any of these 5 things in there, it's non-linear. So most equations we're going to look at are going to be linear. So unless they have one of these funky things in here, it's going to be a linear equation. So right here, I don't even have to look any further. I can see because it has an exponent, it has that x squared, it's going to be non-linear. So they went ahead and filled out a table. So 1 squared is 1, so 1, 1. 2 squared is 4, so 2, 4. 3 squared is 9, so 3, 9. 4 squared is 16, so 4, 16. And then there's our graph right there. And that's not going to be a straight line. And if it continues even more, it would have got even steeper and steeper and steeper. Well, we can tell from there it's not a straight line. So it is not going to be linear. If I do put in a 0, it would go through 0, 0 because 0 squared, but it has to be linear in order for it to be proportional. So that's not going to be it. Okay. Number 3, a soda machine makes 2/3 of a gallon of soda every minute. The amount of the machine makes in x minutes is given by the equation 2/3 x. Determine whether the relationship of x and y is linear, and if so, it's proportional. So first of all, if the machine is on for 0 minutes, it makes 0 sodas. So that makes sense. So 0, 0. So I know right away it is proportional. Then we're going to see if it's linear. So y equals 2/3 x. So I don't see an x squared in that equation. I don't see a square root of x. I don't see an absolute value of x. I don't see x times y, and I don't see an x divided by y. So I'm going to know right away it does not have one of those 5 things. So it is linear. It does have a 0, 0. So it's proportional. So linear and proportional. We could fill out the table just to make sure. So 3 times 2. This is going to be a 6. And then I'm just going to continue the pattern. 0, 2, 4, 6. And then if I graph here, so 0, 0, 3, 2, 6, 4, and 9, 6. So it does go through 0, 0. It is a straight line. So I was right. It is linear. It is proportional. So this homework's going to be a little funny. So I'm going to go through some more examples. Then we'll go back and talk about your homework here in a second. So van charges $20 an hour to plow the snow off driveways. The equation y equals 20x. Gives the cost in y dollars. State whether the relationship between the time and cost is proportional or non-proportional. So y equals 20x. There's no plus a number here, so I know it's going to be proportional. I can graph it as well. So 120, that means 2 hours he'd make 40, 3 hours he'd make 60, 4 hours he'd make 80. So this would be one that would be proportional because there's not a plus anything here, which I'm actually surprised there's not a plus anything there because sometimes they usually charge you for like driving to your house. So they'd be like, oh yeah, I'll plow for $20, but I'm going to charge you $5 to drive to your house. So then there would be like a plus 5 out here or something. So Vance is being pretty nice by not charging you anything for driving to his house. Here you have a rectangular field is x feet wide and x plus 2 feet long. The equation y equals x squared plus 2x gives the area of the field. Determine whether the relationship is linear and if so, whether it's proportional. So remember we had those 5 things to tell if it was nonlinear. X squared, square root of x, absolute value of x, x times y, x divided by y. And I'm looking at the equation y equals x squared plus 2x. And I see it does break one of these rules. It has an x squared right there. So that means since it has an x squared, it is nonlinear. So I'm going to write nonlinear. And it says if it's linear, rewrite whether it's proportional or not, which I don't have to do because it's nonlinear. Here we have y equals 2x minus 3. You have to say whether it's proportional or non-proportional. Again, remember proportional means it has to go through 0, 0. I see a minus 3 there, which means my graph would start right there. So that means it's not going to be linear. So that means I'm going to go up 2 and over 1, up 2 and over 1. So my graph would look something like that. And it's not crossing at 0, 0. It's crossing at negative 3. So this is non-proportional. This one, state whether the relationship between x and y in y equals x squared minus 1 is linear. If so, is it proportional or non-proportional? Again, it breaks one of those 5 rules. They like this same rule that they keep breaking. It is x squared. So that breaks one of those 5 rules. So it ends up being non-linear. I believe that was the last one. Nope, one more. Laura is making rice at a women's shelter. The table Y shows the number of cups she needs for the rice. So for 1, she needs 2.5 cups. For 3, she needs 7.5. 5, she needs 12.5. 7, she needs 17.5. So my X is 1. I'm going to be at 2.5. 3 at 7.5. 5 at 12.5. And 7 at 17.5. If I draw my straight line here, I can keep going if you need to make more rice. So use the graph. So use the data to draw the graph. Is the relationship between X and Y linear? So that does look like it's a straight line. So yes, it is going to be linear. I can also tell it's going up by a constant rate. This is always going up 2, up 2, up 2, up 2. This is always going up 5, up 5, up 5. So since this is going up 2, these are going up 5. I can tell it's going to be linear, but I also graphed it to show that it was linear. All right, so now for homework, it's going to be a little weird. You don't usually do something like this, but you're going to do these 4 questions on page 164. So you're going to do questions 1 through 4. And then you're going to go over to your PMT here. So here's your 6.2 PMT. You can see there are 9 questions. You're going to pick 4 of these questions. So you have 1 through 4 in the book. So 1, 2, 3, 4 questions and 4 PMT questions. So there's 9 to choose from on the PMT. You're picking 4. 4 from the book, 4 on the PMT. So 8 questions altogether. And that would be your homework for the day.